Welcome back to Makerium. In a world driven by imagination and innovation, this channel is where concepts are brought to life. In this video, you are invited into the building process of a bunker, presented as a complete construction guide and intended for anyone planning a cellar, basement, or foundation project. The full footprint of the cellar is excavated to accommodate a concrete basement positioned entirely below ground level. With a required depth of approximately 2.5 meters, the work is efficiently carried out using a backhoe loader, which is well suited for the task. Wooden pegs are driven into the ground to establish the initial layout of the structure, the depths of the piles, the positioning of reinforcement steel, and the final wall elevations are all set and verified in relation to these established level lines. The piles are drilled to a shallow depth of about 80 centimeters. As the cellar structure is already located well below ground level, these piles are not intended to act as primary structural supports, but to secure the reinforcement mesh in position and maintain stability during the concrete pour. Concrete is mixed on site using a mechanical mixer with a standard blend of sharp sand, cement, and water, prepared to achieve a workable and consistent mix. Each pile is filled to about half its depth so the reinforcement cages can be placed easily. The concrete is then poured until the pile is full. This helps reduce cracking and movement, keeping the concrete stable. Long reinforcement rods are added to allow for later work. After the piles are poured and allowed to cure, 25 centimeter spacers are welded to the protruding reinforcement rods. These spacers are aligned precisely with the established axis strings. The reinforcement mesh is then installed, beginning with the horizontal bars. The first layer is placed directly on the welded spacers, and the remaining bars are positioned at vertical intervals of 30 centimeters. Diagonal braces are welded to the pile reinforcement rods, and vertical reinforcement bars are installed at 30 centimeter centers. Once the reinforcement mesh is complete, formwork installation begins. Every board is coated with a release agent before placement, ensuring that concrete does not adhere, protecting the timber and allowing the materials to be reused in future pours. Threaded rods are installed to secure the formwork, with one rod positioned at the bottom, one at mid-height, and one at the top. These rods are essential for resisting the significant lateral pressure exerted by the concrete once the pour begins. Inside the formwork, marine-grade birch plywood is used to create a smooth, high-quality finish on the concrete surface. On the outside, OSB is used as sheathing. Since this wall will be completely buried, a perfect surface finish is not necessary. Horizontal timber braces are installed to resist the lateral pressure of the concrete, while vertical timbers hold the assembly in place and keep it aligned. Extra supports are added inside the formwork, especially near the base, where the concrete pushes the hardest during pouring. If you're following along and enjoying the build, please like the video and subscribe. It's the most effective way to support our work. Concrete pouring begins at the wider bottom section of the wall, allowing it to settle evenly as work moves around the perimeter. The concrete is placed in successive layers, with each section vibrated to remove trapped air and ensure full compaction. For this size of formwork, 8 cubic meters of concrete are delivered and poured. Any imperfections, such as voids, cracks, or honeycombing, become immediately visible once the panels are removed. The wall's integrity is checked, and any potential issues are identified promptly, confirming that the concrete was properly placed and vibrated throughout the pour. Work continues on the second half of the wall, with the reinforcement mesh built to full height. The last horizontal bar is set slightly out of level to fit the slab above. The slab slopes in 3 directions, dropping about 20 centimeters from the center to the edges. Although it looks like a roof, the slope is intentional. It helps the wall resist soil pressure and makes the cellar stronger. The second half of the formwork is now in place, reaching the full height of the wall. At the base, the boards overlap the existing concrete by at least 10 centimeters, creating a tight seal to prevent fresh concrete from leaking through the joint. New holes are drilled through the braces and boards to fit the threaded rods, since the holes from the lower section cannot be reused. Each rod is carefully positioned to hold the formwork firmly and ensure stability for the next concrete pour. Concrete placement starts with a base layer, poured slowly around the edges of the formwork. Properly placing this first layer is important, as it stabilizes the formwork and prevents bulging or deformation from the weight of the concrete poured afterward. Stone-facing work then begins. Any remaining concrete residue is removed using a high-pressure jet washer, and a thick layer of mortar is applied to ensure good adhesion. Large, irregular stones are chosen for their uneven shape, with no attempt made to create perfectly straight or uniform edges. Mortar will not bond properly to contaminated surfaces, so each stone is cleaned with a high-pressure jet washer to remove dirt, clay, and surface dust. While the stones are still damp, a thin cement slurry is brushed on to improve adhesion. There's no point in using good stone where it won't be visible. Even so, the stones still need to be set level, which is not easy given their uneven shapes. The OSB panels and marine grade boards are removed. Thanks to proper surface preparation and the use of release agents, the formwork comes away easily. The concrete surfaces are smooth, clean, and well finished. This confirms that the earlier preparation and work were carried out properly. Stone by stone, the wall begins to take shape. The joints not only create an attractive pattern, but also help lock the stones together. Each row is backfilled with concrete behind. This adds weight and evens out the backs of the stones, helping the next mortar bed spread evenly and hold firmly. A layer of about 10 centimeters of sharp sand is spread across the basement floor. It improves drainage, prevents shifting under load, and helps reduce cracking in future layers. The sand is spread with a rake, filling every corner and covering the entire floor. A leveling screed bar is then used to refine the surface. Old OSB boards are laid out to stop the top slab formwork legs from sinking into the sand during the next stage of work. Before sealing work begins, the first task is to fill all the remaining holes left by the formwork tubes. A stiff concrete and sand mix is packed tightly by hand to fill the full depth and set solid. The walls near the ground are still damp, so a flame torch is used to dry them before waterproofing. 2 full coats of bituminous waterproofing are then applied, and the goal is full coverage. Corners, joints, and the base of the walls, where moisture is most likely to collect, are waterproofed with extra care. Constructing the roofing slab is a complex task that requires exact setup and alignment. A string line is installed along the center of the basement to establish the main reference axis. Accurate layout is essential because the slab has 3 slopes, 1 from front to back and 2 sloping outward from the center. Tripods with adjustable props are positioned and securely locked into place to provide initial support for the slab formwork. Because of the multi-slope design and the heavy weight of the concrete, extensive timber bracing is needed to complete the support structure for the slab. The areas alongside the basement are backfilled in layers. A 30-centimeter thick strip of clean sand is placed directly next to the walls to provide drainage, and the remaining space is filled with clay. This layering helps keep the basement dry and protects the structure from moisture damage. We're installing the remaining props and adding extra support rows. This frame has to hold a lot, nearly 8 cubic meters of concrete, plus all the rebar mesh and the boards on top. Adding the rest of the props gives full support across the entire basement. Next, the slab formwork is installed. Large, thick sheets are used for the formwork to support the weight of the concrete. Each board covers a lot of area, which means fewer joints and a lower chance of concrete leaking through. For all the small cuts and irregular shapes, OSB is used. It's a cheaper material to waste, even though it leaves a rough pattern on the concrete. The gaps are sealed with expanding foam, which prevents honeycombing and strengthens the edges of the boards. Since the backhoe loader is still on site, it is used to place the facade stones. Only the front of the basement will remain visible, finished with a stone facade. Sloped stone walls will be built on both sides of the entrance to tie the basement into the ground level and create a solid, natural-looking entryway. Every stone is huge and has to be carefully positioned to fit snugly. Each one weighs a few hundred kilos, and none of them sit exactly right. The work is slow, tough, and demanding. The edge formwork is made from reused OSB taken from the wall formwork. Rebars projecting from the walls are bent down and tied into the slab's rebar mesh, locking the walls and slab together as one structure. The edge boards are cut to the right height so the slab stays level all around the cellar. They're shaped to keep the concrete in place during the pour. The bottom reinforcement mesh uses 18 millimeters rebars, bent to follow the slab's slope. On top, 10 millimeter rebars hold the main bars in place. Since the slab is 20 centimeters thick, 2 layers of mesh are required. The mesh is spaced every 15 centimeters, and each tie is tightened by hand with a simple hook. Pulling them firmly locks the steel in place, giving a solid, stable base for the concrete. Before pouring, all mud is cleaned off the rebars and formwork so the concrete will stick properly. A concrete truck and pump bring 8 cubic meters of concrete. Even with the slab's slopes, the pour is spread as evenly as possible, using the string line as a guide. The concrete is raked and screeded from the center out to the edges, then finished with a polystyrene float. Work continues on the stone slopes around the entrance. Each stone is cleaned, loose material is removed from the joints, and the gaps are filled with mortar to lock everything together. Over time, small cracks will naturally appear and moss will start to grow, helping the stonework soften and blend into the surrounding landscape rather than standing out as something new. The stone facade is built up slowly. After a layer of stones is set, concrete is placed behind it and reinforced with rebars to hold everything in place. Because the stones are heavy and uneven, only one layer is built per day. The concrete is compacted carefully by hand, using only a simple hand tool to prevent air pockets. No vibration is used, so the stones stay in place and don't get pushed out of alignment. A stone arch is formed at the entrance using a reusable template. Each stone is carefully chosen and positioned to follow the curve of the arch, allowing it to carry its own weight once the template is removed. Rebars are used to tie the arch back into the surrounding walls. Adding strength before the area behind it is backfilled. This slow, step-by-step approach keeps the stonework stable and well supported. When removing formwork after the concrete has cured, it's important to take a careful approach to keep the structure safe and undamaged. Formwork should only come down once the concrete is strong enough to support its own weight and any extra loads. Usually the outer formwork is taken off first, then the internal supports. Any props or shoring inside should be released slowly, step by step, to avoid putting sudden stress on the slab or walls, which could lead to cracking or settling. Back to the stonework. Each layer of stones is backfilled with concrete. As the wall rises, it gets trickier to work, but with every layer, the facade grows stronger and more securely locked in place. Once the arch is completed, the stonework continues up to a few courses above the slab. These additional layers ensure that, when the slab is buried, the stones act as a retaining structure, holding the backfill firmly. The back of the stones is tied with rebars to fully tie the wall into the surrounding structure. Concrete is then placed by hand, shaped to slope from the top of the stones down toward the slab so water drains properly. The backfill is left just below the stone tops, so earth can cover it and blend in once the grass grows. Waterproofing the slab is done with a bitumen roll. Work starts at the lowest point, so each new sheet overlaps the one below, guiding water down and keeping it from seeping under the slab. The roll is unrolled across the slab with a 15-centimeter overlap onto the wall. Once in place, the sheet is pressed down and partially rolled back. It's easier to work with smaller sheets. Use steady heat. Warm it until small bubbles appear. That's when it sticks. If it's dull, it's not enough. If it smokes, it's too much. So the process is done slowly. Heat a section, press and roll it, then move on. After the main surface is secured, overlaps are pressed down and corners trimmed so each layer sits neatly over the last. At all corners, angles, and joints, the sheets are always lapped so water runs over the seam instead of into it, keeping the slab fully protected. Good ventilation is essential in the cellar to keep out moisture, damp walls, and stale air. 4 vertical rebars are drilled into the slab and tied together with horizontal bars to form a solid frame. A simple formwork box is then built around it, and concrete is poured into it. A drainage pipe is placed inside the formwork and wrapped with insulation to keep the vent opening clear. After the concrete hardens, the pipe is pulled out, leaving a neat hole for air to pass through. Now it's time for these old, crusty bricks, the ones that will make the basement look like it's been here for decades. Laying them is a different kind of challenge. Each brick is unique, edges are chipped, and corners are worn. But that's exactly what gives the basement its character. Torch-on waterproofing can't just bend sharply at a 45-degree angle. It might crack or peel over time. So, the slopes around the base of the chimney are shaped, with a few rebars added to keep them in place. The entrance is raised to avoid a steep path, which means the stairs have to step down inside. First, the piles are set to support the stairs and the entrance platform. They don't need to be super strong, so leftover rebars from the build are for reinforcement and are filled with concrete. To build the stair framework, 3 planks are cut to match the full length of the stairs. Each step is 15 centimeters high and 1.2 meters wide. The planks are set so the bottom of the upper plank sits flush with the top of the one below, creating the correct step profile. Used OSB is fixed along the sides to form the stair edges. A rebar mesh is then put together using long bars drilled into the basement wall on one side and tied into the stair piles on the other. This holds the mesh at the correct height. Each step also gets its own mesh, with extra reinforcement along the front edges where the load is highest. To keep rainwater from the path and entrance platform from running inside, a channel drain is installed on a concrete bed. The drain pipe is cut flush with the concrete, so the trench connects directly, giving the water a clear route away. Once everything is set, the concrete pour begins. The stairs take a fair amount of concrete, and each section is vibrated after filling to remove air pockets and voids. The concrete is leveled flush with the top of the planks, so each step ends up at the right height. The key is to hold the putty knife flat, let it glide on its own, and avoid pressing down. To finish, the entrance platform is screeded with a slight slope from the door down toward the drain. This creates proper drainage and leaves the stairs and platform with a smooth, clean, and even finish. A load of sand is brought onto the slab and spread out step by step until the whole surface is covered with an even layer. This layer isn't just for looks. The sand helps with drainage and also protects the waterproofing from clay and stones. A trench is then shaped in the clay about 30 centimeters away from the basement walls and filled with sand. This creates a path for rainwater to run off the slab. After that, a 50 centimeter layer of clay is placed on top to keep winter conditions out. Every load of clay shapes it more, until soon it looks like there's nothing hidden underneath at all. If you've watched all the way through, we want to sincerely thank you. Your support means the world to everyone involved in this project. You are one of our most dedicated viewers, and we truly appreciate it. We're committed to making our next video even better for you. If you enjoyed this one, please consider hitting the like button and subscribing. It really helps us more than you know. Thank you again for your continued support. Once all the stones are in place, the slope is washed with a jet washer. This clears off dirt and mud and cleans out the gaps, leaving the joints ready to be filled with concrete. With the slopes finished and all the joints packed, the basement is finally buried. Just like that, all the work disappears underground, leaving only the entrance visible. To build a solid railing, metal plates are slid onto the threaded rods that were set in during the pour. 6 square pipes are then cut to the right height to form the vertical posts and welded to their base plates. An L-shaped metal piece is anchored into the wall, creating a strong fixing point where the top rail meets the wall. Once everything is positioned, the parts are tack welded together. These small welds hold the pieces in place temporarily, just enough to stop anything from moving. When everything is lined up, the final welding begins. Joint by joint, full welds are completed all the way around, locking the entire railing solid for good. What began as an underground bunker has become something more practical, a cellar built for real use. Most of it now lies hidden beneath the ground, doing its job quietly, out of sight. When spring comes and the grass starts to grow, the buried cellar will disappear even further, covered in green and blending into the surrounding landscape. If this build helped you, stay tuned for more videos coming your way soon. Hit the bell to stay updated, give this video a thumbs up, and drop a comment telling us which part was your favorite.